Hello, today we're talking about dilations. And if you look at the title of the packet, which is the very top, we have dilations. And the way this is written explains what a dilation is. It's the change in size of a figure. Now, a dilation could make something larger. A dilation could make something smaller. It can do either one. So let's look at this first question. Explain in a few sentences why dilations are not isometries. Now, we have some examples. So the dilation is this one right here. We go from here, this rectangle ABCD, to this rectangle A prime, B prime, C prime. As opposed to our isometries, we go from this first trapezoid to the second. We can go from this parallelogram to the second, and we go from this triangle to the second. So if we had to look at the isometries and come up with a definition of isometry that's different than the dilation, then we would need to be talking about similar figures, congruent figures, dilations, and isometry in our explanation. Now, you're welcome to write on the lines on your paper. I'm going to go ahead and just write in this white space sort of next to each one. So I'm going to start by talking about the dilation. For these two figures, these figures are not congruent. Now, we can tell that because they are different sizes. For things to be congruent, they must be the same shape and they must be the same size. However, what we do know about these two figures is that these are similar. So they're the same shape, but they're different sizes. And if I were to find the scale factor relating two sides, for example, CD and C prime, D prime, that would be the same scale factor when I related AC to A prime, C prime, same as AB to A prime, B prime, and BD to B prime, D prime. So we have this situation. But when we look at the isometries, we notice that these pairs are congruent, these pairs are congruent, and these pairs are congruent, which means for an isometry, this is a transformation, which I can't spell transformation, but it's a transformation, where the pre-image and the image are both congruent. So the pre-image is congruent to the image. Okay, so let's look at this. I said the word transformation, so let's see if we can identify each of these transformations. So this first transformation with the trapezoids, our options are, we talked about translations, we talk about reflections, and we've talked about rotations. And we talked about dilations, but we already know that dilations are not isometries, because the two figures are not congruent. So this first one with the trapezoids, that one we have shifted the figure. That is called a translation. In the next one, we haven't shifted them. And if I try and draw a line of reflection, it's not matching up on both sides. So it looks like we've rotated. So this is a rotation. The last one wasn't a shift. We didn't just slide it over, and we didn't rotate it, I don't think. Looks like we reflected it over that line right there, which means this one is a reflection. So our isometries, when we talk about transformations, are translations, rotations, and reflections. The dilation is not an isometry. So if you need more time to write, please pause the video here. I'm moving on to the next page. So in the dilation below, the smaller image is the pre-image, the smaller figure. So I'm going to go ahead and identify our starting image by highlighting it in yellow. So this is what we started with. This is our pre-image. And after the dilation, we ended up with that larger rectangle. So it says, find the scale factor. So again, we started with the smaller figure. So we went from a smaller figure to a larger figure. So let's just talk about that for just a minute. If we're going from a smaller figure to a larger figure, that means we have a scale factor, or what I multiply the small figure by, the scale factor has to be bigger than 1. Because if I multiply by a number bigger than 1, I'm making the figure bigger. So for example, if I were to multiply the length, this length right here I've just scribbled in, by 2, for example, then the new length, sorry, let me count this length, 1, 2, 3, 4, 5, 6, 7, 8. This length is 8. If I were to have a scale factor of 2, the length of my new rectangle would have a length of 16. I would multiply the 8 by 2. So if I had the other situation, and sorry, let's call this something. This is called an enlargement. When I make something larger, it's called an enlargement. Now, if I have a shrink, so to speak, if I shrink something, then that means the larger figure is what I started with, and I do a scale factor and it becomes smaller. That means my scale factor has to be smaller than 1, like a half. That means the new figure will be half as large. So for a shrink, we're taking a larger figure, going to a smaller figure, i.e. shrinking the figure, and our scale factor must be smaller than 1. So that's going to help us try and figure out our scale factor. So to do our scale factor, I need to put one side over another side. But I'm doing an enlargement here. I know that I'm doing an enlargement, I'm making the smaller figure larger. So I'm going to use the widths. So not what I scribbled in already. I'm going to use these sides. This side of the smaller figure, and I'm going to match that up with this side of the larger figure. But what I need to know is I'm making an enlargement, so my scale factor has to be bigger than 1. So what does that mean? That means the bigger number is on top of the fraction. My scale factor is always going to be a fraction. So if my scale factor is bigger than 1, then the bigger number is on the top of the fraction. If my scale factor is smaller than 1, that means my bigger number is on the bottom. And again, our scale factor is always going to be a fraction. Now, if you need more time to write that down, pause the video here as I'm going on. So I need to put one side over the other. I need to make a fraction. And which side is going to be the bigger side? Because I need the bigger number to be on top because I'm doing an enlargement. So is that going to be what I've squiggled in green, or is that going to be what I've squiggled in black? Well, the bigger one is going to be the one I squiggled in green. So let's figure out how long that is. I'm just going to count the length. 1, 2, 3, 4, 5, 6. So that has a length of 6. That's going to go on top. That's the bigger number. Now I have this other side I have in black, and let's count that length. 1, 2, 3, 4. That length is 4. That's going to go on the bottom. Now we typically would reduce our scale factors. So 6 over 4, there's a 2 in each of those, which means I can simplify this. If I take a 2 out of each, 6 divided by 2 is 3, and 4 divided by 2 is 2. So here's my scale factor, 3 over 2. We're not going to write 1.5. Our scale factors are going to be fractions. And again, is 3 over 2 bigger than 1? Yes, because the top number is bigger. Okay, if the top number is bigger, then I have an enlargement. So let's look at the next one. If you need to pause the video to write anything down, please pause the video now. I'm going on to the next problem. So we are plotting these points and then drawing the image under a dilation, scale factor 3, centered at the origin. And we're going to name the image using prime notation. I can actually jump to that part of naming really quickly. So I have triangle G prime, H prime, J prime. Okay, that first letter is a G. It doesn't look like it. So let's plot some points. So first point that I'm going to plot, I'm going to plot G at 1, 3. And you shouldn't need me to actually plot this. And H at 1, 1. And J at 3, 2. Now, this is our triangle that we start with. And now we're going to do an enlargement because our scale factor is 3, which is bigger than 1. So the easiest way to do that is you're going to take your coordinates 1, 3, and you're going to multiply by the scale factor. And our scale factor in this case is 3, which means I'm going to multiply each of the coordinates by 3. So that means G prime is going to be at 1 times 3, which is 3, and then the y coordinate is going to be 3 times 3, which is 9. I do the same thing for the next one, which is not called G. The next one is H. So H is at 1, 1. I'm going to multiply each of those by 3, and 1 times 3 is 3. 1 times 3 is 3. J is at 3, 2. So J prime, 3 times 3 is 9 for my x coordinate. 2 times 3 is 6 for my y coordinate. So let's go ahead and now we can just plot those points and create our enlarged figure. So G prime is at 3, 9. So here's my G prime. My H prime is at 3, 3. My J prime is at 9, 6. And here's my new triangle after the dilation, scale factor 3, which is an enlargement. If you did not get that all finished, please pause the video now. So we're moving on to the next one. So we're going to dilate the following image. The image is already there. We'll scroll down. So we have our triangle right there. We're going to dilate that image under a scale factor of 1/2. And again, we're going to name it using prime notation. With this one, you need to actually write the coordinates down first before you can do the dilation. But what I'd like you to do is I'd like you to do this one right now. Let me scroll down a little bit. So I want you to do this dilation, scale factor of 1/2. So please pause the video now. Here's my solution. I have written the original coordinates in blue on the right. I've multiplied each of those coordinates by 1/2, or in other words, divided by 2 for each coordinate, and written my new coordinates in red on the right. Then I plotted those points. So that is how you would do I guess this is a shrink, but a dilation scale factor of 1/2. So please bring any questions that you have about this video lesson to class, and I hope you have a wonderful evening.